of whether in Pakistan or out of the country, with this slide that behind every successful person there is one elementary truth that somewhere, somehow, and someone cared about his or her growth development, and this person is our mentor. My mentors are Professor Dr. Ahmed and Professor Dr. Mohammed Faraz, who are my mentors during my doctoral of my host institution. As you can see over here, this is P. Meher Ali Shahid Agriculture University, where I have completed my graduation and doctorate. It's a few glimpses are here, but this is on the right side. This is University of Lahore, where I have started my career after the completion of my doctorate, and both of these institutions are very beloved to me. Now come to the topic of my presentation. That is molecular pancreatitis. I'm Dr. Asma Ahmed and working as associate
Dr. Asma,
Yes.
sorry for interruption. I think the slide is not moving.
Okay. How much time
we are still in the first slide.
Sorry, I repeat. Of digestive and endocrine system, and it is located in the abdomen from behind, stretching from behind the stomach and left upper abdomen near the spleen. In adults, it's
Excuse me, Dr. Asma, sorry to interrupt you again. I mean that the slides are not moving. We are still in the first slide. I'm not sure.
Okay. I'm again sharing it.
Please.
Now can you see the movement of my slides?
We are still in the first slide. Maybe you can just stop sharing, then reshare again.
Okay.
That might help.
Now, can you see the movement of my slides?
Yeah, it's moving now. Yeah.
Okay. These are a few glimpses of my host institution, where I have come on the left side PMAS. This is P. Meher Ali Shahid Agriculture University, where I have completed my PhD, doctorate, and graduation. University of Lahore, where I have completed started my career after the post graduation. And the topic of my talk will be molecular basis of pancreatitis. I'm Dr. Asma and working as associate professor at Institute of Molecular Biology and Biotechnology, the University of Lahore. As far as my today's talk is concerned, it is based on pancreatic disorder of the pancreas. Before the disorder and their cure molecular basis, I have introduction about the pancreas, which is an organ of digestive and endocrine system invertebrates, which is located behind the
Sorry, Dr. Asma. Sorry again. I'm really sorry for interruption, but the slide are just like stuck to the second slide. I think you can just do slide sharing, full screen. That might help. Yeah. Otherwise, you need just to.
Can you move
one by
the
one.
Yeah. Slides now? Is it fine?
Yeah, now it's moving actually, but sometimes it's stuck to one slide. Yeah. Maybe there is lag in time anyhow.
Okay. Now, is it moving now?
Yeah.
Okay. I will present in this way, okay?
That's fine, yeah.
Okay. Pancreas is in adults, its size is 12 to 15 centimeter, and it is salmon colored in appearance. As far as it I'm not going in detail about these, and it stretches from down superior mesenteric artery and vein, and its longest part stretches behind the stomach, and its end is connected to the spleen. As far as the ducts are concerned, because this is the disorder of pancreatic ducts as well, it contains main pancreatic duct, accessory pancreatic duct, common bile duct, sphincter of Oddi, and ampulla of Vadar. And as far as the tissues are concerned, it contains endocrine, cystocrine or exocrine. Exocrine tissues make 95% of pancreatic mass, and they are made up of branch echina glands. While it's as you can see in this figure, this is the structure of the pancreas. Its cross section shows the echinus and interlobulated lobular ducts are intercalated. Different echinal cells, and these are the lobules, and these are small cells which are present in the single egg. If we zoom in this pancreatic egg in our cell, we can see over here the Golgi apparatus, zymogen granules, and mitochondria and rough cytoplasmic reticulum. Basically, pancreatitis arises due to problem in all these organelles of the particular problem in mitochondria. And its endocrine tissues are also suffer due to pancreatitis. It is made up of 5 different types of endocrine tissues like alpha, beta, like you will see over here. Yellow color is indicating glucagon producing alpha cells. Red color is orange color is you can see over here gamma. It is involved in the homeostasis of blood glucose level. When blood glucose level reduces, then alpha cells stimulate to release glucagon, and when blood glucose level rises, then beta cells beta cells are stimulated to produce insulin. This is the basic function, basic role which is performed by the pancreas.
Dr. Asma, Dr. Asma, we are not seeing the slide. Sorry for that. And at one time, the voice was like interrupting. Sorry for that. There might be like connectivity issue from your side.
Okay. Can you see my slides now?
Yeah, it's very clear. Yeah, thanks.
Okay, I will share this presentation at the end of my talk as well, so that you can help from this one. Okay, or any problem, and these are there are different methods to diagnose pancreas and its structure, but it is difficult to diagnose pancreas or its problems or its structure due to inaccessibility to the pancreas, fragile organ in the body. And the only option is surgical exploration, which is not fine at the initial stages of the diseases. So the method which are currently in use are physical examination, blood test, and radiographic test. Among them, radiographic tests are the most best one. They are computerized topography or endoscopic ultrasounds or MRIs. While pancreatic duct can be diagnosed, problems in the pancreatic ducts can be diagnosed through ERCP or MRCP. These are different concerned major problems which we are facing right now: fibrosis, diabetes mellitus, and pancreatitis. On pancreatitis and pancreatic cancer. As far as it is concerned, it is a pathologic inflammation in the pancreas. This is the simplest definition which can be dealt to the patient. It can come and go quickly, or it can be chronic as well. It has multiple symptoms like abdominal pain, diarrhea, lower abdominal pain, and its major causes are idiopathic, which can be autoimmune. It can be genetic. It can have CFTRs, and out of CFTRs, along with CFTRs, 3% mutations occur in CFTR and SPA1 and K1 mutations. It is also due to SPA1 and K1 mutations only, or PRSS1 mutations. Third major cause is alcohol drinkage, and its fourth major cause is obstructive. Obstruction can be due to or it can be due to gallstones, to pancreatitis. The overall among pancreatitis, acute pancreatitis is the major one, which happen in 13 to 45 individuals among 0.1 million individuals every year due to activation of due to its activation of pancreatic enzyme locally, due to its tissue injury or pancreatic inflammation, and its molecular basis, so I'm not slide. As far as acute pancreatitis is concerned, nerve cell injury or ductal injury, both of these lead to activation of the trypsin, which to the conversion of the trypsinogen into trypsin. This premature activation of trypsin converted trypsinogen to trypsin, and this activation of trypsin lead to the activation of all these enzymes, all of the digestion of the pancreatic tissue, which is so it become autoimmune, and it lead to the activation of the leukocytes, macrophages, lymphocytes, and endothelium, which lead to the recruitment of cytokines from adhesion molecules and oxygen. They appear in the form of edema, necrosis, bridges, and this recruitment of cytokine, adhesion molecule, and oxygen free radicals lead to the capillary leakage, gut ischemia, regular damage. All of them, these symptoms lead to these different types of infections. And the symbols which I have mentioned over here has been shown at the end of these slides. So I'm not telling their too long. As far as new insight of pancreatitis is concerned, symptom after idiopathic is which lead to increased demand of protein synthesis, may create a pressure on endoplasmic reticulum to synthesize more. Pancreatic toxins also lead to stress, which also create a stress on endoplasmic reticulum to synthesize more proteins, and these more proteins lead to sorry, I will take one pause over here because my okay, sorry for interruption. I will resume. No, this stress on the mitochondria also creates stress on the endoplasm. More and more proteins which and thus leading to the expansion of endoplasmic reticulum. This result as inflammation of the actin. Moreover, calcium signaling is also involved in the pathogenesis of pancreatitis. Like this is a which you can see over here. If toxins, the toxic form of calcium, but as far as CYPD, it attaches to the these receptors on the membrane of the mitochondria, and it mean close. These closures lead to the release of ATP. Activate this CYP itself to the receptors, and these receptors the MTPT channels, and these MTPT channels lead to the depletion of the release of the ATP. So what will happen that matrix will be depleted with ATP, and this mitochondrial depolarization will lead to acute pancreatitis. Bile acids are also involved in the pathogenesis of acute pancreatitis, as this work was done on mice model, in which it was shown that bile acids bind to the bile receptors and lead to increase in 5-LO activity in the equinar cells. This increase in 5-LO activity lead to increase LTP4 synthesis. These LTP4 molecules attached to TRPV1 receptors, which lead to the peripheral release of pro-inflammatory neurotransmitters and causes neutrophil recruitment, edema, and necrosis, and ultimately acute pancreatitis. Is also involved in the
I think we have lost Dr. Asma again. Just a few moments for her to rejoin again.
Share this slide. Okay.
Yes, please.
Yeah, sorry, there was an error.
It's okay, no problem.
As far as hyperglycemia is concerned, you can okay, you can see a storm of LDL, LDL in the blood supply. All of these free fatty acids are lead to the hydrolysis, free fatty acids abuse through hydrolysis of triglycerides, and they become these high concentration of death fatty acids interfere with the endogenous regulation of inflammation, and they promote the increased number of macrophages as well as increase in number of neutrophils in the blood supply. Which is also is pancreatitis. Major problem of pancreatitis arises due to immune mediators, initial pancreatic renal cell damage when either by in autodigestion or any other insult release various moreover any these infiltrating cells lead to the release of various pro-inflammatory cytokines, which lead to the hyperactivation. And this immune hyperactivation lead to uncontrolled local immune response. As you can see in this figure, I will explain it over here. You can see over here, there are two major reasons of autoimmune pancreatitis, like a recruitment of innate immune cells like monocytes, neutrophils, or dendritic cells, and it can be systematic or it can be due to decreased peripheral lymphocyte count, I mean decreased peripheral NK cells, B cells, T cells. When all of these this happen, and it can happen due to sepsis, edema, multiple organ failure. All of these lack on pancreatic, all of these lead to pancreatic infiltration. They infiltrate in the pancreas and lead to the renal damages by the release of cytokines or immunoactivation. TNF alpha, amount of TNF alpha increases, interleukin 1 increases, interleukin 6 increases, acute, moreover, CD4 cells, NKT cells, TRAC cells, PSC cells, all of these, the number of all these cells increases. And this infection is local. All of them lead to the, yes.
Sorry, Dr. Asma, the slide is not sharing. Sorry for that.
Okay. Okay. Can you move? Can you? Okay. Can you see the movement of my slides now?
Yeah, it's
Hello?
clear now.
Okay. So this will be clear now. All of these autoimmune cells, whether they are cytokines or interleukins or other inflammatory cells, the number of all these cells increases within the pancreas, and this damage is irreversible, and it can be local as well. And it happened due to pancreatic injury or recruitment of pancreatic injury. All of these lead to the pathogenesis of acute pancreatitis, which also lead to chronic pancreatitis. And this adaptive immunity is also modulated by smoke and alcohol as well, like smoking, which contain nicotine and its derivatives. These are too much harmful products for the pancreas because they interact with the receptors on the Echinor cells, stellate cells and lead to the release of various chemokines, cytokines, T, and they also affect B cells as well. Moreover, alcohol has negative effect on immunity as well, adaptive immune negative effect. Like smoking, alcohol is not independent involved in the induction of the pancreatitis, but they create predisposition towards the disease progression because they make pancreas susceptible to in chronic infiltrated by T and B cells. You can see here, this is figure which is showing the effect of smoking on the pancreas. This is a strip figure which is showing the effect of alcohol on the pancreas. Like smoking, the cigarettes are these one, they contain nicotine and their derivatives and their lysates. When they are attached to pancreas, they lead to the bioactivation of multiple echinal cells, or they activate their receptors, or they activate macrophages. And I have mentioned already over here that in macrophages, all these NF cells are tumor necrosis factors are interleukins, they become activated. Your tumor growth factors, they all of them, they become activated, and they activate and start either pro-inflammatory action or their anti-inflammatory action. But there is an imbalance between pro-inflammatory to anti-inflammatory action, and this imbalance lead to the development of chronic pancreatitis. And if only anti-inflammatory action happen, if there is a balance in the pro-inflammatory to anti-inflammatory action, then this chronic pancreatitis will not happen, but it will lead to the activation of the acute pancreatitis. As far as alcohol is concerned, it either block CD cells, alter lymphocyte count. Both of these experiments have been done in the mice, and higher level of androgens alcohols are from bacteria. All of these lead to chronic pancreatitis by increased number of T and B cell infiltration and pancreatic fibrosis. Tryptogen activation is also involved in the genesis of pancreatitis. Like if any pathological event happens, it can be smoke, it can be alcohol, it can be any injury. All of them lead to the activation of the trypsin, and the trypsinogen will be converted into lysosomes. Moreover, it will also affect mitochondria. But all these lead to necrosis, but this infection will be local and systemic as oxidative stress is also involved in the activation of the pancreatic beta cells, like a xenobiotic load, aortic boom. They can activate phase 1 pathways of CYP enzyme, which attach to which increases the solubility of compound which are more bioactive, because these are oxidative stress mean increase in the number of the oxygen. Xenobiotics are involved in production of free radicals. They can be oxygen free radical, nitrogen free radical, anyone, and these free radicals increase in the path of ion pathway, and this lead to the bioconjunction or reduction, and this ultimately increase the number of oxidative species. Inadequate if the body is deficient from antioxidative defense, then the body oxidative stress lead to inflammation. This inflammation lead to increase in NF-kappa B activation, calcium dysregulation, or pancreatic stellate inactivation. All of them ultimately lead to the release of zymogen activation and protease release, and cell injury, fibrosis, necrosis, which are the major reasons of chronic pancreatitis. These are different inflammatory mediators in acute pancreatitis, like IL-1 beta, IL-6, IL-8, PF. All of these are inflammatory mediators, which whose number increases in case of pancreatitis. Now, mechanism of NLRP3 inflammation activation during acute, they also increases during acute inflammation, like in pancreatic injury. What happens? These NLRP3 inflammasomes, their number increases basically inside the echinal cells, right? And all their number increase like here, and inflammasomes lead to the release of the cytokine, and this is the symptom which is that pancreatitis from surgery. Stress, as I have already told you, stress is forced to make more proteins, and that might be due to the increase of granule if there is these are sequence of the diseases. If pancreatitis happen, then zymogen granules will block the pressure, and then the blood will be under stress, and it will lead to proteasomes this will lead to autophagy, and the destruction of endoplasmic reticulum by autophagy or proteasome. Both of them lead to destruction of protein in this tree cell, which will reduce the death of the cell. And it causes can you movement of my slides now? Okay, these are different causes of endoplasmic reticulum stress, and these are different consequences of the stress. Both consequences lead to the cell death. Moreover, inflammatory responses in pancreatitis include the release of, again, this is the summary of the autoimmune pancreatitis, like it lead to the increase in the number of neutrophils, lymphocytes, macrophages, increase in the number of cytokines, interleukin factors, TNF alpha beta factors, and all of them ultimately lead to, this is the cell of the Achener cell. It's a cytoplasm contain those inflammatory genes which are not required within the normal cells. The cytoplasm contain all those factors which are not required within the cell, and the cell membrane is affected by different interleukins or TNF alpha beta factors or different inflammatory cells. Now, genetic, how chronic pancreatitis is involved with genetic development, is concerned with genetic development. It is either intrapancreatic zymogens are involved, or first line defense is inactive, or second line defense is inactive, or autodigestion. Any of these four factors can lead to the diagnosis of the can lead to the prognosis of chronic pancreatitis. It basically classified on the basis of genetic development. This chronic pancreatitis is either intrapancreatic or first line damage in the first line defense, or damage in the second line defense, which lead to autolysis. And first, in intrapancreatic zymogen activation lead to autoactivation of the Achener cells, while excessive activation is due to first line activation of the first line defense molecules, and activation cascade has started, and it doesn't stop due to the activation of second line defense, due to the activation of second line defense, while zymogen autodigestion of zymogen activation lead to pancreatitis. And it is an autosomal dominant hereditary disorder as well. It is transferred from affected parent to the children, but this ratio is 50 to 50%, meaning if one parent is healthy, other is disease, suffering from hereditary pancreatitis, then there is an option that this daughter can be the carrier, while son can be the can be suffering from hereditary pancreatitis. And it is due to this is the structure of the protein which is affected during pancreatitis. You can see over here the structure of the trypsin, in which different channels and active sites have been shown which are affected during hereditary pancreatitis. This is the model which shows the pathway of hereditary pancreatitis and inherited pancreatitis. This model is actually this model was actually tested on mice model, and this is the pathway of hereditary pancreatitis. And I have already discussed it that it is due to the activation of trypsin in trypsinogen into trypsin, and in which SP1 NKX is exhausted, and lead to the autolysis of the trypsin, and this autolysis lead to the inactivation of the trypsin molecule. If there is no inactivation, then trypsin is again synthesized, and it lead to the zymogen activation, which lead to the autodigestion of the Achener cells, and it lead to the pancreatitis. How we can manage this disease? We have different modes of methods and modes through which our bodies our body try to manage pancreatitis. First one is potent GLP-1 and agonist are given to the patient, which exert effects by multiple mechanisms, as they are presented by different red colors, like you can see over here. Number one, this potent GLP-1 agonist amplifies glucose-dependent insulin release. Or number two, you can see over here, it can this GPL1 analogs suppress appetite. They can also slow gastric emptying, and they do this or these three mechanisms. Moreover, they inhibit glucagon release. These four factors are basically these four mechanisms. These four effects are basically produced after the intake of GLP-1 agonist by the patient. Second option is use of UCN3, which promotes somatostatin secretion from the delta cells in an incretin-like fashion. Like you can see over here, this is the isolate of tangerine in which glucagon glucagon is released from the alpha cells. And these UCN3 cells promote the release of somatostatin, and this somatostatin lead to the cure of pancreatitis, right? These are different potential therapeutic targets and their pathways. These are different agents like GSK 77 target is QRA1, and their target is basically calcium. They basically store operated calcium entry channels and calcium signaling pathways, and their status is preclinical. Mean these agents have been tested on these target pathways, but their status is either preclinical or phase 2 trial, or either they are commercially available, or they are on pilot scale production, or they are on commercially available, but there no trials have been conducted, or they are present at preclinical trial stage. Okay. Different hypothetical mechanisms which have been suggested for the protective action of gibberellin, leptin, and melatonin on acute pancreatitis. Like these are the three different three different compounds, and it has been suggested that leptin, melatonin, and gibberellin can have strong effect on acute pancreatitis. Like leptin can act on the brain and lead to the activation of nerve CRGP release, while gibberellin act on the brain and lead to the activation of sensory nerves. And as far as melatonin is concerned, melatonin act on the through L-tryptophan. Melatonin is produced and it act on the pancreas directly, and thus lead to the suppression of these different pro-inflammatory and inflammatory cytokines, interleukins, T and alpha factors. All of these and all of the pancreas, and moreover, this melatonin also increases blood flow to the pancreas. And this melatonin is also involved in the reduction in the number of macrophages, NPOs, and neutrophil segregation. And all of these, these three molecules lead to the protection of the pancreas from acute pancreatitis. Different compounds or chemicals which are present in the market for protection against pancreatitis are aprotein, trypsin-like serine protease inhibitors, anti-inflammatory agents, cyclooxygenase inhibitors, lipoxygenase, and TF antagonist of natural religion. But my focus, my field of research is basically pharmacognosy, using different phytocompounds. I have added 2 phytocompounds. I have not tested, but they are reported in literature as well. These are different phytocompounds which are mentioned in dark blue color, and they have been derived from these plant sources, which can be used as a cure or as a preventive measure against pancreatitis. I'm extremely thankful to Higher Education Commission of Pakistan and Government of Pakistan, who have provided me an institute like Institute of Molecular Biology and Biotechnology, University of Lahore, for the completion for the collection of this data, because this is not research-based data, this is a review-based data. I'm also extremely thankful to the organizing team of Diabetes 2022 for giving me an opportunity to present my work over here. These are different abbreviations which I have used during my talk. These are all abbreviations. I have added them. And these are the few claims of my city, Lahore. Whenever you come to Pakistan, any one of you come to Pakistan or come to Lahore, and you come to University of Lahore, you may meet me, or you can visit Lahore through different services as well. Now, thank you so much, all of you, for listening to me. If you have any questions, suggestion, or comment, I'm available. You can give it to me. Thank you.